Hello there. Today I'll be taking you through a question on moles, and we did this question in the other session, and I'm continuing with the same. Therefore, in this question, it is reading that 6.84 grams of aluminium sulfate were dissolved in 150 cubic centimeter of water. Calculate the molar concentration of the sulfate ion in the solution. Then we've been provided here with the RFM of aluminium sulfate, which is equals to 342. Therefore, when it comes to this question, I normally advise my students that you need to understand the concept of the question. If you look this question, you've been given aluminium sulfate. Then in the question, you've been told calculate the molar concentration. Underline the important area, the molar concentration. The molar concentration means the molarity. It means the molarity. Then of the sulfate ion, we have those two areas that you need to understand. The molar concentration, I said it is molarity. And when we say molarity, it is number of moles. Number of moles in 1 liter or 1000 cubic centimeter or 1 cubic decameter. That one you need to understand. Therefore, when it comes to this question, first of all, we need to write the equation of the aluminium sulfate once you put it in water, because it is going to dissolve. Since we say all sulfates are soluble except lead and barium, therefore this one will dissolve once you put it in water. Therefore, we are going to have aluminium sulfate. Here is 2. This one is 3. You put it in water. Therefore, it is going to dissolve and separate into aluminium ion. Aluminium ion with the 3 plus there, plus what we call sulfate ion with the 2 minus there. This one is aqueous, definitely. This one is going to be an aqueous. It's going to be an aqueous. Therefore, this one is an ionic equation. It is ionic equation. Therefore, from there you balance the equation. You have it 2 aluminium, 1 aluminium. Therefore, I put 2 there in order to balance. Then I have 3 sulfate. I put 3 sulfate there. From there, let's come to what we call mole ratio. This one is called mole ratio. Mole ratio is 1:2:3. This 1:2:3. From there, we have been given the grams of aluminium sulfate, which is 6.84 grams. Therefore, we can be able to get the moles from here because we already have the RFM. How do we find the moles? Moles is equals to mass all over RFM. And now, since we are having the mass here, which is 6.84, you divide by the RFM, which is 342. Definitely, we are going to get moles as, therefore, if I take my calculator here, I'm going to have 6.84 to divide by 342. We get 0.02. That is 0.02 moles. That is 0.02 moles. Therefore, for this one, it is 0.02 moles. And for this one, since the mole ratio is 1:2, 1:2, therefore we can be able to get the moles for aluminium by multiplying by 2. 0.02 multiplied by 2, you get that is 0.04. Again, for this one, since it is 1:2:3, I'm going to have 0.02 multiplied by 3, you get 0.06. Therefore, for the sulfate ion, since I'm concentrating the sulfate ion, I already have the moles. And in this one, we have been told that it was dissolved in 150 cubic centimeter. Therefore, when I come here, I'm going to say if these moles 0.06 moles are in 150 cubic centimeter, how about in a 1000 cubic centimeter? I'm I'm going to have how many moles. But now here, I'm supposed to find the value of x, whereby to get the value of x, I'm supposed to cross multiply. Therefore, x is going to be given by 0.06 multiplied by 1000 divided by 150. Therefore, once I work out that, I'm going to get 0.06 multiplied by 1000, then I divide by 150. I get 0.4 capital M. This is a molarity. Therefore, in our question, we are told to calculate the molar concentration. The molar concentration of sulfate ion is going to be 0.4 moles per 1 liter. Thank you so much, as I'm looking forward to also have an interaction with you in other subjects, mathematics, biology, and languages. Asante.